Okay, it's more clear. So when firewall receive the packet, basically it looks for the ingress information, and in the ingress information it would look for for layer 2 information, layer 3 information, layer 4 information. So all these stuff it is going to look. If any of the information is missing, right, in the ingress, so this is going to drop the packet. So if we talk about layer 2 information, that means MAC address, layer 3 information, that means IP address, layer 4 information, that's port number, ingress interface, that on which interface it is coming, okay, and zone lookup, it would look the zone as well. And if it is required to fragment the packet, okay, or reassemble the packet, so it would do that. Okay, so it would look all those information and then it would move further, right? So if there is anything missing on the packet, okay, it would drop. If there is everything is okay, okay, ingress process has no error, then it would go for the next things, which is firewall inspections. So it would check whether the firewall inspection is applicable on this. Okay, if yes, so it is going to going for the IPsec VPN. It would check whether the packet is for the IPsec VPN or not. If the packet is coming from the IPsec VPN, so again it is sending to the tunnel interface, okay, and that tunnel interface would do the decryption of the packet, and then it would forward the packet further to again on the packet ingress process, so that it would be able to see the layer 3 or layer 4 information which would be contained into the packet. Because then in IPsec packet there would be two type of header. When you put IPsec header on the packet, what it would happen, usually that is going to hide your private IP which is within the packet. So that means if you receive the IPsec packet, if the packet is coming from the IPsec, okay, so in that packet there would be some certain information. So you would see one information where you would see the public IP, okay, which would contain source IP and destination IP of the packet. And within the packet, if you extract the IPsec packet, okay, so within the packet you would say the private IP.
But can you explain what all the L2, L3, L4 information will be there in that? L2 stands for the physical MAC address.
So L2 in L2, basically it is going to, let's say if this is a notch or layer 3 packet, okay, that means if this is containing the source IP and destination IP, it is not containing the, this is not layer 3 packet. Okay, so
and
in that,
and how we can identify the how Palo Alto can identify that this is the L2, L3, L4 information.
Okay, so basically on the packet itself, there would be information.
This was about to going to say.
Yeah.
So as Vaibhav is also new and we are also new to the Palo Alto right now, so can you tell me that what all L2, L3, L4 information will be there? So it will be a brush up for us, and for Vaibhav it's a learning.
Yeah, sure. So let me just explain about L2 information. So on L2 information, let's say you are sending packet from a source A to source B, destination B, and in between you have a Palo Alto firewall.
Okay.
So if you have configured this Palo Alto for on L2 mode, right? So in this Palo Alto firewall, there won't be any layer 3 information. That means there would be no IP, okay, but still they can forward the packet based on the MAC address. So here on the when source A sending the traffic to B, so on the packet, data packet, it would be putting some information, Okay. So basically on your packet, there would be two segments. One is your MMS,
Multi maximum segment,
maximum
Segment,
MMS, sorry,
maximum MSS, maximum
MSS,
maximum
maximum
maximum maximum
segment
segment
size, segment size.
right. So here would be your actually datagram. This would be your datagram. And other thing, your MTU. So MTU is a complete thing, and this is your
Transmission unit.
header. Yes. So this is you can say this is a header. So when we say that the traffic is going from source A to destination, so usually on header they are putting layer 2 information. If this is a layer 2, so here they are going to put source MAC address and then destination MAC address. Okay, and here would be actually your data. So when Palo, this source is going to send any data to destination B. On that case, here it would, the Palo Alto on this interface, it is going to look source MAC, destination MAC. Okay, this is one information. Then it would look that on which particular port they are sending the data. Okay, and then it would look that whether this is what is the ingress interface. Okay, and zone. So these information it is going to look on the layer 2. But let's consider this is a layer 3 packet. That means the A want to route the packet to B side. So on that case, instead of source MAC address and destination MAC address, they are going to put source IP and destination IP. So usually what happens, they use a 6 tuple the information over here. Right
and
here.
on which layer we change the source port and the destination port?
So we will see here on layer 4 address.
Okay, in the transport layer.
Yeah, in transport layer.
Okay.
So usually, when any packet receive on the Palo Alto firewall, and let's say this is normal packet. So they use a 6 tuple. We can say this is a 6 tuple information. When I say 6 tuple, that means they are going to contain number 1, source IP and destination IP. In information in here, it is going to check source IP and destination IP. That is the first thing. Then
Source port, destination port.
Source port and destination port. Now you have a 4 information, destination port. Third number, it is going, no, protocol is there already because it checks the source port and destination port only.
Yeah, okay.
Okay, then you can see this is the 4 information has been completed. Then further they are going to check protocol number. Whether this is TCP or this is
UDP. Yeah.
Okay, and then they are going to check the zone. Okay, that means not a destination zone, but it is going to check ingress zone. So these are the 6 tuple information.
So ingress zone stand from the computer A which is sending,
Right,
or to the computer B?
yeah, this is ingress zone actually.
Okay.
This side would be ingress zone. Always source side would have the ingress zone and destination side would have the egress zone. So the when Palo Alto would receive the packet, it would check these 6 information. If this is a layer 3 packet, okay. If this is layer 2, so source address, destination MAC address, it is going to check. Rest of the things would remain same. Okay, and also it would check whether this required a packet reassembly, because if the packet is fragmented, so yes, it required to do reassemble. So here it is going to check all those things. If there is any error, let's say source zone information is missing, okay, on the packet, so immediately this is going to drop the packet. So in interview, people can ask the question, what if you don't assign any zone to particular interface, okay, and you are trying to send the packet, whether that interface accept any packet. So usually no. However, you have defined the policy, but you haven't assigned the interface into any zone. So by default, whatever the packet is coming to this interface, it would get dropped, right? So if everything is right, packet is fine, okay. So it would go to further step where it is going to check the firewall inspection, whether the firewall inspection is applicable. So if applicable, I mean, whether it should go via the firewall or not. So if it is applicable, then this is going to check further whether this packet belongs to IPsec or this is a normal packet. So let's say this is not a normal packet. This is the IPsec packet, right? Which required a decryption. Let me just move here.
Oh, I was just copying that thing.
Amar, I have one doubt. You mentioned that in L2 we have source MAC or destination MAC addresses.
Yeah.
Is it? But how
Yes.
they can identify the destination MAC address? If it is a first time communication, then source we know. Means source
This is
MAC address.
yeah, because
How they can
eh,
extract that MAC address, destination MAC address, because it is far behind from the means. Suppose we are using some tunneling is there, means SSL connection is there, or it's means MAC address is coming from the
so
neighbor
it would
only.
be always default MAC address,
Okay.
that side. Yeah.
For L2 means for me means like that
L2
L2
means L2 information just like
ARP
yeah,
ARP of the machine means
yeah,
it's
ARP
working
of the
on
machine,
ARP.
right?
That's fine. We can means I think it's like this.
Yeah,
Okay. Yeah, please carry on.
sure. So let's say this is IPsec packet, and for this IPsec packet, what it is required? It is required that packet inside the packet, whatever your private IP. So those private IP should be read by the firewall so that it would be able to understand that whether this packet required to be passed through the firewall or not. Because until it doesn't decrypt the packet, it won't be see that what is actual datagram within the packet. So in IPsec, we have let's say if you encrypt any packet using IPsec layer, so basically it contains two things. One, it is containing overlay IP, okay, which is visible for everyone. So that means on the packet you can see the overlay IP. That means source IP and destination IP you can see, and those would be the public information. Okay, public IP. And the other thing would be underlay IP. Underlay IP. So underlay IP is nothing but your private IP within the IPsec tunnel. So this is a private IP. So this is a private IP we can say. So what here required? Here actually required to see that private IP. Okay, and the content which is going through the firewall. So it should be able to see that. So in that case, this would do decryption, and when it decrypt the packet, it is just going to remove this IP header, okay, and then it is going to pass through that traffic again from the ingress and egress process so that it would be able to understand layer 3 information, ingress interface and egress interface. So egress interface always would be your tunnel one, okay. So it would be able to identify that this packet, this is IPsec packet, and its egress interface would be tunnel interface. And further, again, if there is any error on that packet, so it is going to drop it. If there is no error, so this is going to check whether the firewall inspection is applicable or not. If the inspection is not applicable, then it is going to create and install the session. Sorry, this is going to forward the packet immediately if inspection is not applicable, and if inspection is applicable, then it is going to be further. So let me just clear this. So up to here, you understand, right? Let's move to here.
Yes.
Now let's understand. Now your packet is going to be here, okay? Where it is going to check the session further, post the IPsec review, okay? If this is the normal packet, it's not a IPsec packet.
This
In
is a
that
first
case,
time packet, no? We
yeah,
can
this
that
is
we are
this is a first time packet.
okay.
So first time packet has been reached here on the firewall fast path, okay, to fast path checkup, right? So in fast path checkup, this is going to look that whether the any session is matching session is found or not. So if there is any matching session found, then it is going to further over here on the layer 2 to 4 firewall processing, okay, where it is going to check the netting, etc. But if the session is not found, if this is a first time packet, so where it is going to send that packet?
Slow path.
Forward the forwarding lookup
Forwarding lookup.
via slow path, okay? So this would go to the slow path. And in slow path, what it would do, basically, it is going to look up the forwarding table. That means the destination routes. And if there is any special routes, which we can say that um, packet based policy based forwarding PBF, right? So if there is any special route we have created which is policy based forwarding, so it is going to look up that. And if there is no special based forwarding and we just have the routing table, so here it is going to look the that route, that how the packet would go to the destination, for the destination whether there is a route available or not. So all those things get checked here, okay?
Yes.
And if there is anything, okay, missed, for example, if it is not able to know that what would be the egress interface or what would be the destination zone, so if it would not be able to know that, or if there is no destination, unknown destination, okay, which firewall doesn't know that how to route that packet to the particular destination, then it is going to drop that packet, okay? And in case of layer 2, so here it is going to look for the layer 2 forwarding database. Basically, this is going to look the, if we compare with the Cisco service, basically it is going to look the CEF table over here. Okay, whether for that particular destination, MAC address is present or not. So all these things it is going to look up. If everything is okay, it is going to check the NAT policy, whether the NAT policy destination NAT is present, matching any kind of NAT policy is there or not, okay? If there is a destination NAT present where destination need to forward to a specific destination, so in that case this is going to look up the second forwarding lookup to get the final or real egress interface. That means you can understand in this way. I would talk about the destination NAT over here. So let's say this is a system which has generated the traffic towards your firewall, and let's say this is outside interface, okay? And we have one of the interface which is DMG interface. So what we did basically, let's say this DMG interface got the IP 172.16.2.10, okay, which is a private IP. And what we did, we have netted this system, okay, through one of the public IP, right? And we perform the destination net. So let's say public IP which I have on this interface, which is 100.0.0.10, and the netted IP for this particular system, we have 100.0.0. Let's say 50. This is my netted IP. Now, when you might have looked into the Palo Alto that when you do the netting, so in netting rule, what you usually look, the traffic from outside to outside, means source and destination, you assign basically outside. So if the packet from outside to outside, the source is outside, usually it is hitting outside, and the destination you also look, put the outside over here. So when you define there, what you usually use to define? in netting policy, you define source and destination zone as the same, okay, over here. But in actually, when it do the final netting, where it need to be routed, it need to be routed towards the DMZ zone. So here, what it would look through the destination zone, which is your DMZ, right? Final
Yes.
destination it is going to check over here. So with the net policy, it would be able to evaluate what would be the final or real egress interface. Okay, that's why it checks for the destination over here, destination netting. So here it would check the net policy, but it would not apply the final netting. Final netting would be applied on the egress time, right? So net policy is present, then fine. If not present and it got the source IP and destination, source zone and destination zone, then there is no problem. All right, then after the net policy lookup, what it is going to check? The firewall policy.
First, they will means it is check the net, then it will check the policy.
Right. Post source checking the net, it would check the policy. Why it is required? Because it required to get the real interface. Okay, and that's why net policy is checked first. So now it would look to the firewall policy, and in firewall policy, it would have mentioned over here that if there is any application is used, okay, if there is any rule is matching with that or it is not. So if rule is matching, so it would look that on the rule whether the action is allowed or action is dropped. So if on the rule action is dropped, so this is going to discard the packet. If action is allowed, then it is going to create the session, and that session it is going to install into the Palo Alto Firewall. That means this is going to update the session. Okay. In that case, if let's say the session is, I mean, when session is matched, let's say session is already matched. Okay. So this is just going to avoid all these things. If there is any packet coming which is already being passed through the firewall and session is being matched, so it is not going to send that packet via slow path. Then this is going to follow the fast path. Okay, but let's say that in case of session is matching, but that session is not active state. In that case, what it would do, it would discard the packet over here only.
What
Right?
it mean that it not in active state? If that
Session is not in active state. Let's see that the TCP session is there. Okay, and let's say usually or any ping session we can take. Okay, so let's say I'm just pinging the traffic. Okay, but this firewall did not act. I mean, do not have a active connections. Okay, for a particular source and destination. In that case, this is going to discard the session.
no means my question is like if it will match the existing table routing table session. That means that connection already been there. Is it?
Yes, that means
Then
the
why
connection is
they
already there.
there? But then why they mean that connection is active?
Yeah, if the traffic is going through the firewall, yes, connection is active state. But let's say session is not active, means the traffic is not going through the firewall, right? So there is a idle time for a particular session. After that, this is going to discard the packet.
Okay.
Discard the session means. So we can take the example of any UDP. Let's say UDP session timeout is 30 seconds. Okay. So let's say you are sending any kind of DNS traffic through the firewall towards 8.8.8. Okay. In that case, what it would do, basically, it is going to check that this I mean, when you send the packet to this IP, so it would keep that session active till 30 seconds. After that, if next packet doesn't come, so it is going to discard that.
Okay. That means that
That's what.
it continuously, if the traffic is coming to the firewall, that means that session is there, and it will allow all the sessions. Otherwise,
Right,
after 30 second and whatever the timing of TCP, that traffic is not coming, then session would be discard.
right. So that's the thing. So here it is just going to update the session, and it is going to update the lifetime of that session as well. Okay. So sessions, it is going to update and define the lifetime that this session would be TCP type, so it should be active for 60 minutes. This is UDP type, so it should be active for 30 seconds. And I think ICMP, that should be active for 1 minute. So accordingly, according to the protocol, this is going to define the lifetime of the session. Okay. Post this, if it required to do netting, okay, if netting is required, it is going to do here. Okay, it is going to do the final netting. And if packet is your encrypted packet, that means, let's say this is not a IPsec packet, but you received SSL packet, any kind of SSL packet. That means, let's say you have received HTTPS packet, okay, which is required to be decrypted so that it should identify the application, what is the content inside the packet, it should be able to identify. So if packet is, encrypted, so it is going to decrypt the packet using SSL proxy if you have enabled the SSL inspection on the firewall, so that it is going to look the packet for the decryption. So if the packet is encrypted, so it is going to use SSL proxy to decrypt the packet. Okay. And further, you can see here, after this is going to check whether the session app ID app has been identified, means within the session application is identified. If application is already identified by the firewall, then good. If not identified, this is going to send that packet to the for the application identification.
Yes.
Yeah, where it is going to check the application override policy, app override policy, whether you have just skipped the actual application checking. Okay, so if there is any application override policy you have created, this you would do in case of if you have a generic application, and for that you just want to define application ID. So that's application is developed in your organization, but Palo Alto doesn't know that the behavior of that application, how it works, and that's why it haven't released the application ID. Because if you know that standard application, let's talk about the Zoom or Facebook or any other standard application, so Palo Alto does know about that application and the behavior of the application, how it is going to generate the packet, what would be the packet sequence gaps, all those things Palo Alto does know. So if Palo Alto does know about that, then it is going to give the application ID. But let's say you have the custom application ID application, which is just developed by your organization, but Palo Alto doesn't know about that. So for that, basically we write the application override policy. Okay, some of the parameter we can just tweak. So if we have created any application override policy, okay, where we just define that this is organization application, and for that actual application should not be checked. So it is going to look that if we haven't defined any policy, okay, in that case this is going to look into the security policy lookup based on the application. That means if we haven't defined if you haven't defined any application ID, sorry, this is wrong. If you haven't defined any application ID, then it is going to look the data pattern of the traffic, and based on that it would be able to identify the application. Okay, but if we have defined the application override policy. Then it is go further and it would looks for the security policy lookup based on the application. According to application, it would looks for the security policy. And if it is going to check whether that particular application is allowed or not on the rule. Okay, here it has checked based on the port. Here it is checking based on the application. So whether that application is allowed on the rule or not. If this is not allowed, so it is going to discard the packet. If it is allowed, so then it is going for the further one where it is going to send the traffic for the content inspection. So content inspection is nothing but this is a SP3 model, because you know in the content inspection this work on the single pass parallel processing.
Yes.
So it is going to send the packet for the SP3 model. So in content inspection, it would set up SP3 if the security profile you have set up. In Palo Alto, basically you define the security profile so that accordingly firewall should check the content security, right? That means antivirus, URL filtering, IPS, okay, which is known
I
as
have
threat
a
protection.
question.
Yeah.
So SP3, how much it is faster? It's as we compare with the 48 packet flow.
Okay. I don't have answer for that exact how much it is faster, but same thing it is not going to look up. That means
See, Pratik means SP3 is basically they are just checking all the QAs, all the policies at a single time. Not policy, these applications and QAs content inspection they are in the single within one MS. Within one MS, they can inspect.
less than 1 ms itself.
Within one MS. I'm saying it's very small amount of time. It's milliseconds. Within milliseconds, they inspect.
But we can say that basically, you know, if we talk about SP3 model, so they don't route packet again and again for the same things to be checked up, right? So that's the SP3 model does. So in a single go, they are going to look for the content, they are going to look for the application, they are going to look for the user, all these things. So they are going to look into the single go.
Okay.
Okay.
Yeah. So you know this would go to content inspection, okay. And if there is a application is SSL kind of application, so basically this is going to mark that application